Project Management Professional Training Session 13 Part A. Monitoring and controlling the project. You need to continually monitor and control your project. In general, monitoring means watching the course, and controlling means acting to either stay the course or move away from the wrong course. When applied to project management, you monitor the project via activities such as taking performance measurements to see that it is on the track set by the project management plan, and you control the project to keep it on track and to bring it back on track if it falls off. The core of monitoring and controlling the project includes collecting the work performance information, the raw data, from the project's execution and analyzing it for performance, which includes comparing it to the accepted performance baseline consisting of the scope baseline, the schedule baseline, and the cost baseline. This comparison generates performance measurements, which may then lead to some change requests. The change requests must be processed through an integrated change control system for approval, and only the approved changes should be implemented. The performance measurements may also expose some previously undetected risks. We will study all this in this part of the book. Monitoring and controlling the project work. PMP exam objectives: what it really means. 4.1 Measure project performance. Measure project performance using appropriate tools and techniques in order to identify and quantify any variances and corrective actions. Here, it really means that you must understand the monitor and control project work process, including the earned value analysis technique, variance analysis, trend analysis, and creating change requests to maintain course or bring the project back on track. 4.2 Manage changes. Manage changes to the project by following the change management plan in order to ensure that project goals remain aligned with business needs. It means that you should know how change requests are handled in the Perform integrated change control process inside out, and how the requests are created in the monitor and control project work process, as well as other monitor and control change processes, such as the control procurement process. Continued. PMP exam objectives: what it really means. 4.3 Verify that project deliverables conform to the quality standards. Verify that project deliverable. You need to continually monitor and control your project, that is, monitor and control the project activities against the project management plan and project performance baseline. This is because executing a project means executing the project work according to the project management plan based on some baselines, such as a schedule baseline, a scope baseline, and a cost baseline. In general, monitoring means watching the course, and controlling means taking action to either stay the course or move away from the wrong course. You monitor the project by collecting project performance data, generating performance measurements from it, and distributing this information in the form of performance reports, which can be used to control the project. You can control the project by measuring the performance deviations by comparing the actual performance results with the planned performance and proposing changes based on these deviations. Controlling also includes influencing the factors that generate the deviations, processing the proposed change requests through the integrated change control system, which contains a process called the Perform integrated change control process, evaluating their impact across the project, and ensuring the implementation of the approved change requests. Every knowledge area has one or more processes from the monitoring and controlling process group. In this chapter, we will cover the monitoring and controlling processes in integration management, quality management, risk management, and procurement management. So, in this chapter, we will start by exploring the big picture of monitoring and controlling the project and then venture through 3 avenues: monitoring and controlling project work and performing integrated change control, controlling quality and monitoring risks, and controlling procurements. Monitoring and controlling the project, big picture. As just mentioned, you monitor and control your project by monitoring and controlling the project performance and resulting changes. It includes measuring project performance and evaluating performance information to see the trends, and also taking action to keep the project on track. Continuous monitoring helps the project management team identify the areas that need to be controlled closely, for example, by taking corrective or preventive actions. Note: monitoring and controlling does not start only after the project starts execution. Rather, the project needs to be monitored and controlled all the way from initiation through closing. A project is monitored and controlled using the monitor and control project work and perform integrated change control processes, which are high-level processes performed by executing more specific processes, such as control cost, control schedule, and control scope, as shown in Figure 12.1. All processes shown in Figure 12.1 are in the monitoring and controlling process group except the direct and manage project work process, which belongs to the executing group and is discussed in Chapter 9, and the close project or phase process, which will be covered in the next part of this book. As illustrated in Figure 12.1, work performance data and deliverables generated by the direct and manage project work process are used by the monitoring and controlling processes. Deliverables by control quality and work performance data by all except the monitor and control project work and perform integrated change control processes. Two main output items of these monitor and control processes are the work performance information, by all except the monitor and control project work and perform integrated change control processes, and change requests, including plan changes and recommended corrective and preventive actions. Work performance information goes into the monitor and control project work process as input, and change requests from any processes or stakeholders are processed through the perform integrated change control process for approval. If approved, the execution or implementation of these changes is managed using direct and manage project work, a process in the executing process group. By using work performance information, the monitor and control project work process generates the work performance reports that are used by the perform integrated change control process. Study Checkpoint 12.1. Name 3 processes that convert work performance data into work performance measurements. In the monitoring and controlling process group, the monitor and control project work process and the perform integrated change control process belong to project integration management, which as you saw in Figure 12-1 work as high-level umbrella processes under which other monitor and control processes are running. In this chapter, we will discuss the monitor and control project work, perform integrated change control, control quality, monitor risks, and control procurements processes. The rest of the monitor and control processes will be covered in the following chapters. We will start with the monitor and control project work process and the perform integrated change control process, which belong to project integration management. Monitoring and controlling project work. Monitor and control project work is the high-level process for monitoring and controlling the project's progress to ensure that the project is on its way to meeting its objectives as laid out in the project management plan. Monitoring and controlling here means tracking, reviewing, and reporting the project progress. You monitor by collecting data on or measuring some project aspect and assessing how the measurements and trends would affect the project performance. You control by determining changes, example, corrective or preventive actions or modifications to the plan, following this up with action, and checking whether the actions taken have resolved the problem. Some of the major tasks performed during this process include the following. Monitor the project performance by comparing it against the project management plan in terms of parameters such as cost, schedule, and scope. Evaluate performance to determine whether it needs to be controlled by taking corrective or preventive actions. Monitor the project by analyzing raw performance data to support status reporting, progress measurement, and predictions. Monitor risks by tracking and analyzing the already identified project risks and identifying new risks. Control risks by managing the execution of risk response plans when the risks occur. Maintain an accurate and timely information base regarding the project as it progresses. Monitor and control changes and monitor the implementation of approved changes, example, from the performance data. Tip: the most important overall goal of the monitor and control project work process is to make sure that the project remains aligned with the organization's original business needs. The monitor and control project work process is presented in terms of input, tools and techniques, and output in Table 12.1. Input to monitor and control project work. The major inputs to this process are the project management plan, to look at any aspect of the project, and the work performance data that result from directing and managing the project work for analysis. We also have project documents, including 1. Milestone list with scheduled dates for specific milestones to check if they are being met, 2. Project schedule forecasts to determine if the project is within defined schedule tolerance ranges, 3. Bases of estimates for information on how the various estimates were made and how they can be used to determine responses to variances, 4. Cost forecasts of the project's past performance, used to determine if the project is within the defined budget. Tolerance ranges and to identify any necessary changes. 5. Issues log, which shows who is responsible for resolving specific issues by a target date. 6. Assumptions log for information on assumptions and constraints identified as affecting the project. 7. Change log, which contains the status of all change requests. 8. Risk register for information on threats and opportunities that could possibly impact project execution. 9. Risk report for information on the overall project risks and also on specific individual risks, such as risk sources. 10. Quality reports for information on quality management issues, corrective actions, recommendations for project, processes, and product improvements, and summary of findings from the control quality process. And 11. Lessons learned register for information on effective responses for variances, as well as corrective and preventive actions. Enterprise environmental factors used as input to this process include the project management information system, infrastructure for facilities and equipment, the risk tolerance level of the stakeholders, and industry and government standards. The organizational process assets that can be used to perform this process include financial control procedures, management procedures regarding issues and defects, risk control procedures, the process measurement database, and the knowledge base repository for lessons from past projects. Tools and techniques for monitor and control project work. The tools and techniques for the monitor and control project work process are meetings, decision-making, expert judgment, and data analysis. You already know about meeting management by now. Decision-making techniques. Depending on the organization, project, and matter, any of the following different decision-making techniques may be used. Decision by voting. This can take different forms, such as by simple majority, by two-thirds majority, and by open or unanimous voting. In a voting system called plurality, a group or option carrying the largest vote wins even if it's not a majority. This situation arises when there are more than two alternatives. Plurality with two alternatives is simply a majority method. One vote can represent an individual or a group. Autocratic decision-making. This is a technique where one individual makes the decision instead of the entire group. Multi-criteria decision analysis. This is an analytical technique to make a decision. In this technique, you have a set of predefined criteria, and you use a number of systematic analytical methods to evaluate the requested changes. Then, you make the decision by comparing the analysis result to already chosen criteria. Expert judgment and data analysis. Expert judgment can be sought if needed on topics relevant to this process, such as contract management, risk management, technical knowledge of focus area of the project, decision-making techniques, or any of the data analysis methods listed in Table 12.2. Table 12.2. Data analysis methods listed for the monitor and control project work process. Any technique need chapter. Cost-benefit analysis helps to determine the best corrective action in terms of cost in case of project deviations. 7. Earned value analysis to get an integrated perspective on scope, schedule, and cost performance. 13. Root cause analysis to find out the main reasons for a problem, example, to identify the reasons for a deviation and the areas the project manager should focus on to effectively achieve the project objectives. 9. Trend analysis forecast future performance based on past and present results. 12. 15. Variance analysis determine and analyze the differences, or variances, between planned and actual performance. 13. Alternatives analysis. Select corrective actions, preventive actions, or both, to implement as a response to deviation. 5. 6. Output of monitor and control project work. The output items of this process are described in the following paragraphs. Work performance reports. The raw work performance data, a main input into this process, is turned into information by data analysis techniques and is then presented in work performance reports. These reports are distributed in physical or electronic form among the appropriate stakeholders for various purposes, such as to raise awareness, help make decisions, or take action. Status reports and progress reports are two common examples of work performance reports. To help the stakeholder effectively comprehend the information, these reports can use appropriate presentation tools, such as tables, charts, such as reserve burn-down charts, histograms, such as defect histograms, and graphs, such as earned value and trendline graphs. Change requests. You will compare the work performance data or the analysis thereof with the planned performance. Any deviations will produce some change requests, such as those to adjust project scope, product scope, quality requirements, or schedule or cost baselines. Change requests may necessitate the collection and documentation of new requirements. We have already discussed such changes in some detail in the Direct and Manage Project Work Process coverage in Chapter 9. Caution! Original change requests, such as those in project scope, product scope, or cost baseline, if approved, can trigger other changes, such as those to the project management plan, project documents, or product deliverables. Project document update. Based on the results of data analysis, any input document may be updated. For example, new risks identified will be recorded in the risk register, new issues will go into the issues log, and changes in cost forecasts will modify the cost forecasts document. Study Checkpoint 12.2. Q1. The performance of a project is measured against which planning element? Q2. Can you name 4 baselines? As you have leaned, change requests arise from monitoring and controlling the project work, from directing and managing project work, and from any other source, such as the stakeholders. These requests must be processed through the Integrated Change Control process, formerly called Perform Integrated Change Control. Performing Integrated Change Control. The Perform Integrated Change Control process is all about processing change requests, which includes evaluating the change requests, deferring, rejecting, or approving them, and managing the implementation of approved changes and the changes resulting from this implementation. A project rarely runs exactly according to the project management plan, and therefore deviations will inevitably occur. Change requests can come from evaluating the project performance to bring the project in line with the project management plan, or they can come from other sources, such as the stakeholders. Regardless of where they originate, it is the project manager's responsibility to manage all the changes, which includes getting the changes rejected or approved, ensuring the approved changes get implemented, and changing the affected plans and documents accordingly. Note other things about changes and this process. The Perform Integrated Change Control process is used to manage changes to the project from project initiation through project closure. Process changes, depending on the project, performing organization, and particular request, the authority to determine whether it be deferred, rejected, or approved might lie with the project manager, the sponsor, or some kind of committee, example, Change Control Board, CCB. The CCB may consist of individuals from upper management and other stakeholders. Even after CCB approval, an approved change request may require the approval of other stakeholders, such as customer or sponsor. As noted earlier, to incorporate the approved changes, some other changes may be necessary, such as updating the project baseline, cost, schedule, and scope, to maintain its integrity. Tip: especially in a startup organization, you will notice quite often changes making their way through the back door, for example, a product manager talking to an engineer directly and introducing changes. Do not consider yourself an opponent of changes by default, but you do need to manage changes and make sure each change goes through the integrated change control process. So, when it comes to changes, the key word is control, and not necessarily oppose. The Perform integrated change control process is presented in terms of its input, tools and techniques, and output in Table 12.3. Tip: the key benefit of this process is that the changes get documented, they are considered, deferred, rejected, or approved. Approved ones are implemented in the entire context of the project, and changes resulting from the implementation are managed. This reduces the risk that would prevail in absence of this process. Input to integrated change control. Each requested change and recommended action must be processed through the Perform integrated change control process. The approved changes have their effects on the project management plan, and therefore the plan needs to be updated accordingly. The following are the input items to the integrated change control process. Project management plan. This is needed for change-related information, e.g. the change management plan contains information about managing the change control process, along with the roles and responsibilities of the Change Control Board, CCB, and the role of the project manager in the change request approval process. The other relevant project plan components include configuration management and scope, schedule, and cost baselines. We also need the project management plan because some of its components may need to be updated as a result of the applied changes. Project documents. The project documents that we may need for information and updates include bases of estimates, requirements traceability matrix, and risk report, discussed earlier. Work performance reports. The performance report is input because the reported performance deviations from the plan are important when evaluating the resulting change requests. We described these reports in the previous section. Change requests. These are obvious inputs. A requested change goes through an approval process where it can be approved, rejected, or delayed. Enough has been said about these changes in this and previous sections. As said earlier, change requests may include the following types of recommendations. Recommended corrective actions. Recommended preventive actions. Recommended defect repairs. These recommendations might arise from different sources, such as from performance evaluations, the output of various control processes, and stakeholders, as illustrated in Figure 12.2. Enterprise environmental factors. The enterprise environmental factors that can influence the integrated change control process include organizational governance, contracting and purchasing constraints, legal and regulatory requirements and constraints, and government and industry standards. Organizational process assets. The following organizational process assets can influence the change control process. Organizational procedures. Your organization may have proper procedures related to change control, for example, how to modify documents, such as plans, how to process, evaluate, approve, or reject changes, and how to implement the approved changes. Project files. Project files from previous projects may be a useful input to the change control process in order to learn from the past. Change knowledge base. This is the knowledge base that can be used for configuration management, such as official company standards and policies and project documents, different versions of these. So, what tools and techniques are available to process these requests and recommendations? Tools and techniques for integrated change control. Expert judgment and meetings. Expert judgment can be sought on topics of technical expertise to evaluate change requests, risk management, configuration management, and legal issues, legislation, regulations, and procurement. The project manager or project management team can also hold meetings with experts and the Change Control Board to evaluate changes and make approval/rejection decisions about change requests. Change control tools. The change control tools actually refer to manual or automated tools for both configuration control tools and change control tools. Configuration refers to a specific arrangement of elements in a particular figure, form, or combination. Some examples are the settings of options in a computer program, the distribution of electrons in a particular atom, and the spatial arrangement of atoms in a molecular bond. Configuration control is mainly about deliverables and processes, example, facilitating identifying, documenting, reporting, verifying, and auditing. Change control is mainly about change, e.g., facilitating identifying, documenting, postponing, rejecting, approving, and tracking changes to the deliverables, baselines, project documents, etc. Data analysis and decision-making techniques. These techniques are used to assess the change requests and decide whether to postpone, reject, or approve them. The data analysis techniques may include alternatives analysis to help make a decision about which corrective actions, preventive actions, or both to implement as a response to deviations, if the change request is accepted, cost-benefit analysis to determine if the change implementation is worth its cost, and so forth. We can easily apply decision-making techniques, such as voting, autocratic decision-making, and multi-criteria decision analysis, which were discussed in the section on the tools and techniques for the monitor and control project work process. Output from integrated change control. The changes that are processed through the Perform integrated change control process will either be deferred, rejected, or approved. As a result of the approved changes, the project management plan and project documents might need to be updated. Accordingly, the following are the output items of this process. Approved change requests. You must make sure not only that the approved change requests are implemented through the direct and manage project work process, but also that the status or info about the deferred and rejected change requests is communicated to the stakeholders who requested the change. The dispositions of all change requests are recorded in the change log as a project document update. Project plan and project document updates. As a result of approved changes, components of the project management plan may need to be updated, such as baselines and any subsidiary plans. Also, project documents may need to be updated, such as the change log, which is used to record changes that happen during the project lifecycle. Figure 12.2 illustrates the big picture of the change control process. Caution! During document updates, changes to any baseline are made in reference to the last baseline version of the baseline going forward, keeping all the versions intact in order to preserve the integrity of the baselines for historical data of past performance. Study Checkpoint 12.3. Q1. Many processes in the monitoring and controlling process group generate change requests. Name the process in this process group that is used to approve or reject the change requests. Q2. Name the processes and other sources that can generate the change requests. As shown in Figure 12.1, project deliverables, an output of by the direct and manage project work process, need to be verified by the control quality process. Also, quality control measurements used as an input in the quality management process, discussed in Chapter 9, come from controlling quality, the process discussed next. Controlling quality. Quality is controlled by performing the control quality process, which is a high-level process that oversees and controls the quality management activities with the goal of making sure that the project outcome is complete and correct. To that end, the following is accomplished. 1. Verify that all the planned requirements and specifications have been implemented and complied with or conform to. 2. To be specific, measure the completeness and compliance of the project in its outcome. 3. In these measurements, include all steps, variables, and attributes. Note the phrase project outcome is complete and correct says it all because it is complete and correct, it has met all the planned requirements and hence meets stakeholders' expectations, and the project outcome does what it is supposed to do. Table 12.4 presents the control quality process in terms of input, tools and techniques, and output. Core of performing quality control. The key word in the control quality process is verify. Performing the control quality process can be explained in the following steps in terms of the items from Table 12.4. 1. Get how-to information. This process is performed according to the quality management plan. 2. Get what to verify. You run verification on deliverables and work performance data from the direct and manage project work process. The work performance data, already discussed in this chapter, includes quality schedule and cost quality information, measurements for technical performance, quality metrics, and other quality information such as that from observations. 3. Verify. You perform various tasks to run verifications, such as the following. Inspect the deliverables to determine if they conform to the standards as planned, and examine if they meet the acceptance criteria defined in the project scope statement. While doing this, use information from the work performance data. Also, use deliverables and work performance data to verify that approved change requests from the Perform integrated change control process are correctly and completely implemented. Run tests from test and evaluation documents from the Manage Quality process to check the quality of the implementation and if various project and product variables comply with quality standards as specified in the quality metrics. Also, test and evaluation documents perform evaluations about overall quality objective achievements. 4. Generate output. From the information and results obtained from these verifications, you can generate the output of this process, such as quality control measurements, verified deliverables, work performance information, and change requests. Caution! Note that according to PMBOK you are using the project scope statement in the preceding steps, but Table 12.4 does not have the project scope statement as input. The same is true with the outputs of the control processes, such as performance reports, test reports, and variance analysis used in the Manage Quality process where you perform document analysis. Study Checkpoint 12.4. Q1. Which quality process generates quality control measurements? Q2. Which quality process uses quality control measurements? Q3. Which quality process generates quality metrics? Q4. Which quality process uses quality metrics? To facilitate verification, you can use a plethora of tools and techniques, discussed next. Data gathering. The following techniques can be used to collect data both for and during verification, example, inspection. Questionnaires and surveys. This technique, discussed in Chapter 2, can be used to collect data about customer satisfaction with the project outcome. Statistical sampling. Statistical sampling involves randomly selecting a part of the population for study. In quality control, you can select a subset of features for inspection, measurements, and quality verification. This can save a substantial amount of resources. To get reasonably accurate results, make sure that the sample is random and is of reasonable size, i.e., not too small. Quality checklist. A checklist is a structured tool used to verify that a predetermined set of required steps has been performed. The checklists can come in imperative form, such as to-do lists, or in interrogative form, such as have you done this lists. Checklists are prepared or identified, if they already exist, in quality planning and used in quality control and are part of the input in test and evaluation documents. Check sheets. In many data collection scenarios where you want to put the data in an organized form, a very useful tool called check sheets or tally sheets can be used. This tool is particularly suitable when data to be collected is about the variables, example, different types of errors in a software module. For example, Table 12.5 presents different kinds of errors found in a sample of software modules during inspection. Data analysis. You perform root cause analysis, discussed in the Manage Quality section, to identify the root causes of defects. Also, you can analyze and measure the quality metrics defined in the Plan Quality Management process using the work performance data and then compare these measurements with their planned values. This is called the performance reviews. Data presentation. In this process, data presentation techniques are used to identify causes of defects, find the potential effects of quality defects and errors, rank defects and their causes, and find if the processes are stable. Scatter diagrams. A scatter diagram is used to show the pattern of the relationship between two variables, an independent variable and another variable that depends on the independent variable. The dependent variable is plotted corresponding to the independent variable. For example, a variable representing a cause, such as temperature, can be the independent variable, and a variable representing the effect, such as operational errors, can be a dependent variable. The closer the data points are to a diagonal line, the stronger the relationship, called the correlation, is between the two variables. Scattered diagrams can be used to find the causes of defects. Histograms, in general, a histogram is a representation of the distribution of numerical data. It could be a bar chart that shows a distribution of variables. Each bar can represent an attribute, such as defects due to a specific cause, and its height can represent the frequency of the attribute, such as number of defects. This tool helps rank the defects and causes behind those defects, and also ranks the processes in terms of numbers or frequency of defect. You might ask, how many defects is acceptable? To find an answer to this question, you need to understand another tool, called the control chart. Control charts, in general, are used to determine if a process is stable, i.e., if its performance can be predicted. In other words, they are used to monitor whether the variance of a specified variable is within the acceptable limits dictated by quality control. A variance is a measurable deviation in the value of a project variable, such as cost from a known baseline or expected value. This is a way to monitor the deviations and determine whether the corresponding variable is in or out of control. The values are taken at different times to measure the behavior of a variable over time. The mean value in the control chart represents the expected value, and a predetermined spread from the mean value, usually plus or minus 3 sigma, is used to define the limits within which an acceptable value can fall. Control charts can be used to monitor the values of any type of output variable. To illustrate their main features, consider the example of a control chart shown in Figure 12.3. In this example, assume that a manufacturer produces 100 units of a product each day, and it is expected that 95 out of 100 units should have no defects, that is, the expected number of defective units is equal to 5. The control limits are set to plus or minus 3. In other words, 95 units out of 100 must be correct, give or take 3. That puts the lower limit at 92 and the upper limit at 98. Crossing the lower limits is not acceptable to the customer, and crossing the upper limits might require an unjustifiable cost. Controlling quality includes dealing with defects and the problems that cause them. So, studying causes of a problem is critical to quality control. Caution: the upper and lower limits are based on requirements set in the specifications, while control limits are statistically determined from actual data on how the process is performing. As mentioned earlier, control charts, in general, are used to determine if a process is stable, and their particular uses can include monitoring volume, cost and schedule variances, and frequency of scope changes, as well as tracking repetitive activities to produce manufacturing lots. Cause and effect diagram: a cause and effect diagram is used to explore all the potential causes, inputs, that result in a single effect, output, such as a problem or a defect. This type of diagram is the brainchild of Kaoru Ishikawa, who pioneered quality management processes in the Kawasaki shipyards, and Figure 12.3. An example of a control chart. Therefore, these diagrams are also called Ishikawa diagrams. Due to the shape of these diagrams, they are also known as fishbone diagrams, and because of what they do, i.e., find multiple causes, they are also called YY diagrams. For example, to construct and use cause and effect diagrams effectively, you can perform the following simple steps. 1. Identify the problem. Write down the problem in a box drawn on the right side of a large sheet of paper. This represents the head of the fish. Starting from the box, draw a horizontal line across the paper. This represents the spine of the fish. 2. Identify the possible areas of causes. Identify the areas or factors from where the potential causes of the problem might come. Environment, people, materials, measurements, and methods are some examples of areas, factors, of causes. For each factor relevant to the problem under study, draw a line off the spine and label it with the name of the factor. These lines represent the fish bones. 3. Identify the possible causes. For each factor, identify possible causes. Represent each possible cause with a line coming off the bone that represents the corresponding factor. 4. Analyze the diagram. Analyzing the diagram includes narrowing down the most likely causes and investigating them further. Figure 12.4 shows an example of a cause and effect diagram. The problem in this example is the delay in the release of a website. The factors considered are environment, methods, people, and time. Of course, the diagram is incomplete in the sense that more factors and related causes can be explored, and causes for each factor can be explored further. But you get the point.